So we can find the zeros of a quadratic equation. So we have a quadratic equation here, x squared plus x minus 12. And we can factor this quadratic into x minus 3, x plus 4. And we can say that the zeros, or this equation is equal to 0, is going to be at x equals 3, because if I substitute 3 into here, this all equals 0. If I substitute negative 4 into here, this equation all equals to 0. Now, when we take this same quadratic and graph it, okay, this is a function now, we can see that the quadratic is going to look like this, and the zeros are going to be, where it crosses the x-axis, are going to be at 3 and negative 4. So what happens then is, if we have zeros, we can put it into factored form. So we can start with the zeros at 5 and negative 2. And what we can say then is, if we have zeros at 5 and negative 2, we can factor into x minus 5, x plus 2 equals 0. Okay? And we know that this quadratic in factored form can be expressed in this way. And the same can be done with the function. If we have zeros at negative 2 and positive 5, we can put this into factored form, and we can express it as this general form equation. So if we have the zeros, we can write this function in factored form very easily, and vice versa. If we have the factored form, we can write the function in factored form very easily. So if we have the zeros, we can write the factored form, or the other way around. If we have the function, we can write the factored form. We know where this graph crosses the x-axis. So this helps us draw this function if we know these 2 points. And these 2 points are very useful because they are symmetrical. In fact, since they are symmetrical, we can find where that vertex is if we need to. Okay, because we know that that vertex is going to be along this line of symmetry. And we know that if we have any 2 symmetrical points, we can find the middle point by using an average formula. So we have to note though that if we have this quadratic, y equals x minus 5, x plus 2, we know where the graph crosses the x-axis. There should be a 0 at negative 2, there should be a 0 at positive 5. But the problem is that given the factors, we don't know where this graph, if this graph is a regular parabola here, it could be a wide parabola from just the zeros, okay, it could be upside down. We still have to solve for A, because there is going to be a difference. Given these 2 points, there's lots of different parabolas that pass through those exact same points. So if we have the factors, or the zeros, we can come up with part of the equation, but what is still missing is there is this A value that can change. Okay, so there's an A value here, and there's an A value here. And that's very important that we remember that the factors by themselves do not complete the function. It only tells us 2 points in the function, and there are multiple graphs that go through those same 2 zeros, so we need another coordinate to establish the A value. So I'll give you an example here. We'll do this problem. If we start with the zeros, okay, we can write this equation in factored form. It's going to be x minus 2, x minus 4. Now, this is not the complete equation because we still don't know which direction it's opening. We don't know if it's expansion or compression. And to do that, we need this coordinate. So if I sketch this graph at 2 and 4, at x equals 2 and x equals 4, we have this graph here, but we don't know if the graph is going to go this way. We don't know if it goes this way. We have no idea. However, once we fix this coordinate at 3, negative 12, maybe down here, we have a very good idea what this graph looks like. In fact, this happens to be the vertex because we can tell because it's halfway between those 2 points, it's symmetrical. And then we know that this is probably some kind of a thinner parabola that's facing up. Okay, so that A value can then be established with that one coordinate. Okay, so we can then solve. So we're going to plug in y is negative 12, x was 3, and then work out this parabola. So work out this equation, solve for a. So we end up with negative a equals 12. So yeah, negative a equals 12. So a is equal to positive 12. This is a vertically expanded parabola with an a value of 12. So this is going to be equal to that 12 was solved by using that point, by plugging it in. So our factored form is 12 times x minus 2, x minus 4. Okay, and if we don't solve for that a, we've only done half the problem. So here's another one where we've been given the zeros. So we can come up with the factors, x minus 3, x minus 2. Now it has a y-intercept of 12, and we have to remember that the y-intercept is only for the general form. This is not the general form. So if we just put in there plus 12, okay, that's a big no-no. This is wrong. Okay, that's very important that we don't do plus in there. It's factored form. We have to only have factors. We can't have these plus pieces in there. So then how do we use that y-intercept of 12? Well, we have to remember that there is an expansion compression factor here that has to be solved for. And that y-intercept is just another coordinate we can use to solve for a. So x is 0, y is 12. So when we plug this in, we end up with 6a equals 12, a is equal to 2. Okay, so it's very important that we solve for that a. So we end up with the a equals 2. So my function looks like this, and we write it in factored form. We have our a value, and then we have our factors. Okay, and we cannot forget about that 2, because that fixes the direction of the graph. If I were to just draw this graph with the zeros, I have a 0 at 2 and 3. The y-intercept is up here at 12. Okay, then that 12, this y-intercept gives us an indication what this graph looks like. So now once I have that y-intercept, I know that graph is going to look like that.